Okay, so to verify this identity, again, we're going to choose to work with either the left or the right side of this equation. So usually working with the more complicated looking side is the way to go. So we're going to start with the left here. So I'm just going to copy down the left side of this, these two fractions. So getting a little sloppy there, I apologize for that. So tangent alpha plus secant alpha and tangent alpha minus secant alpha are the denominators of these two fractions. Well, you got two fractions, you got a plus sign in between, so we need a common denominator. So the common denominator, we would have to multiply these two denominators together, which, since they are conjugates of each other, will make tangent squared alpha minus secant squared alpha. So that's going to be the common denominator. So what we're going to have then, what we're going to have to do is multiply the numerators also to build these fractions up to where they have this common denominator. So the first fraction, well, what did I do to get this common denominator? On the first fraction, we multiplied by tangent alpha plus secant alpha. So you do the same thing on the top. So the top will be -1 times tangent alpha plus secant alpha. The second fraction, what we needed to do here is multiply by tangent alpha minus secant alpha on the top and the bottom in order to get our common denominator. So tangent alpha minus secant alpha. Okay, so let's think about this tangent squared alpha minus secant squared alpha. Let me change colors here for just a moment. So we have an identity that says tangent squared alpha plus 1 is equal to secant squared alpha. That's our identity. It's the usual form for that to be written in. So secant squared alpha is equal to tangent squared alpha minus 1. So figure out what tangent squared alpha minus secant squared alpha would be equal to. Well, if we subtract secant squared alpha from both sides here, then subtract 1 from both sides, wouldn't we get -1 equals tangent squared alpha minus secant squared alpha? So this is just scratch work up here kind of in the corner. So -1 is equivalent to our denominator here, tangent squared alpha minus secant squared alpha. So would it be okay with you to just get rid of the -1's? -1 divides out with the -1 that is equivalent to our denominator. So now what's left? Well, what we have left here is tangent alpha plus secant alpha plus tangent alpha minus secant alpha. So the secant alphas would add to 0, secant alpha minus secant alpha, and what's left then is 2 tangent alpha, and that's exactly what we needed to come up with to verify this identity. Hope that helps. Let me know if you need another one.